Attention! This channel provides original historical analysis based on sources and research. We do not simply recount events, we analyze their causes and consequences, explaining them through original narration, editing, and visual diagrams. A list of sources is included in the description. Enjoy watching. Welcome back to the channel. Today we are looking at a real historical event, one that changed the course of armored warfare in the final months of World War II. This is not a story about a battle won by numbers alone. It is a story about a secret, a weapon, and the moment an entire army lost faith in its own invincibility. Let's begin. March 6, 1945, Cologne, Germany. The cathedral still stands. Around it, the city has been reduced to layered ruins, collapsed facades, fractured streets, entire city blocks compressed into rubble fields by months of Allied bombing and artillery. Yet inside this devastation, German armored crews hold their positions. Panthers, a handful of Tigers, veterans who have survived 3 years of the most brutal tank warfare in modern history. They are outnumbered, undersupplied, and in continuous retreat. But they still believe in one thing with absolute certainty. Their tanks are better than anything the Americans can field. That belief is about to cost them everything. The confidence these men carried into combat was not the product of propaganda alone. It had been built and verified through thousands of engagements across 4,000 kilometers of contested ground, from the desert corridors of North Africa to the hedgerow country of Normandy. It was forged in the specific arithmetic of armored combat, and that arithmetic had consistently favored Germany since the summer of 1942. In August of that year, the Tiger I entered combat near Leningrad. What followed was a systematic transformation of armored warfare doctrine across every theater where the vehicle appeared. The Tiger's 88mm KWK-36 gun could destroy any Allied tank at ranges exceeding 2,000 meters. Its frontal armor, 100mm on the hull, 120mm on the turret face, absorbed fire from Allied tank guns that struck at combat ranges and deflected it without penetration. These were not exaggerated performance claims. They were engineering specifications confirmed in field conditions, documented in Allied after-action reports, and repeated in the testimony of survivors on both sides. The standard American M4 Sherman carried a 75mm M3 gun. Under ideal conditions, at ranges under 100 meters, that gun could penetrate Tiger frontal armor, provided the angle of impact and ammunition type were both correct. In practice, those conditions rarely existed in combat. The Tiger's crew, meanwhile, could engage a Sherman with confidence at 2 kilometers, at which distance return fire presented no meaningful threat. The asymmetry was total. German heavy tank crews developed a professional relationship with this asymmetry. Veterans of Schwere Panzerabteilung 506 described it in consistent terms. Not arrogance, but certainty. A calm, technical understanding that at range, inside a Tiger, they occupied a category of threat that Allied armor could not answer. They documented their kills with precision, painting rings on gun barrels. They developed tactical habits built entirely around the assumption of firepower and armor superiority. Those habits had kept them alive. The engagement at Villers-Bocage in Normandy on June 13, 1944, became the single most cited demonstration of what this superiority meant in operational terms. SS Obersturmführer Michael Wittmann, commanding one Tiger, engaged a column of British armored vehicles on the main road through the town. In under 15 minutes, he destroyed 14 tanks, 2 anti-tank guns, and 13 other armored vehicles. The column was halted. The advance was delayed. Wittmann himself would be killed in August 1944, but the action at Villers-Bocage had already entered the operational consciousness of both armies as proof of what one well-crewed Tiger could accomplish against numerically superior but outgunned opposition. By late 1944, German armored doctrine had institutionalized this advantage. Commanders positioned Tigers and King Tigers at maximum engagement ranges, exploiting superior optics and gun velocity to destroy Allied armor before it could close to threatening distances. Defensive lines were drawn around the assumption that a single heavy tank, correctly positioned, could hold a road junction for hours against a column of Shermans. That assumption had been validated repeatedly. There was no tactical reason to question it. On the Allied side, the psychological effects had become operationally significant. American and British tank crews had developed what historians would later document as Tiger fever, a distortion of threat perception in which the weight of German armor reputation shaped battlefield decisions regardless of what was actually present. Units reported Tiger contacts in sectors where German records confirmed only Panzer IVs operated. Infantry refused to advance when Tiger activity was suspected but unconfirmed. The myth had acquired independent operational force, functioning as a force multiplier without requiring the physical presence of the weapon. Allied command understood the problem clearly. The solution being developed in classified facilities across the American Midwest was not tactical, it was industrial, and it was progressing under a level of operational security that the German intelligence apparatus would fail entirely and consequentially to penetrate. What the veteran crews holding Cologne Cathedral Square could not know on the morning of March 6, 1945, was that the answer to everything their Tigers represented had already arrived in Europe. It had been unloaded at Antwerp on January 26 under cover of darkness, listed in cargo manifests as heavy maintenance equipment. It was sitting in a 3rd Armored Division motor pool less than 40 kilometers away. The myth of German tank invincibility had been earned over 3 years of combat. It would be broken before the afternoon was over. Write in the comments what city you are from and subscribe to the channel. That is the best support you can give us. And we move on. The M4 Sherman was not a bad tank. That distinction matters because the story of its replacement is sometimes told as though American engineers had simply failed. They had not. The Sherman was designed in 1941 with a specific enemy in mind, the Panzer IV, Germany's primary medium tank at the time, equipped with a short 75mm gun of modest velocity and limited armor penetration capability. Against that threat, the Sherman was adequate, reliable, and manufacturable at the industrial scale American strategy required. It was a rational engineering response to a defined problem. The problem changed. The Sherman did not. Were not competitive. At Sidi Bouzid in 1943, American armored units in North Africa were encountering Tiger I tanks in combat for the first time. The engagements were not competitive. At Sidi Bouzid in February 1943, American forces lost over 100 tanks across 2 days of fighting. Many were destroyed at distances where their own guns could not respond effectively. German armor engaged from 1,500 meters, sometimes further, and the 75mm Sherman gun had no answer at those ranges. The field reports that reached the Army Ordnance Department in Washington carried a consistent and urgent message. The gap between what American tanks could do and what they were being asked to do had become operationally dangerous. The formal response was a development program designated T-26, authorized in September 1942, though preliminary engineering work had begun earlier, as early indicators from the North African theater had already suggested the Sherman's limitations were structural rather than fixable through incremental upgrades. The objective was precise and unambiguous: produce a frontline battle tank capable of engaging and destroying German Tiger and Panther-class vehicles at normal combat ranges. Not a tank destroyer operating from concealment. Not a specialized anti-armor vehicle with limited tactical flexibility. A tank capable of holding ground, supporting infantry, and killing the best armor Germany could field. The scale of the industrial effort assembled to achieve this objective was without precedent in American armored development. 14 primary contractors were brought into the program, supported by more than 300 subcontractors distributed across 22 states. The geographic dispersal was deliberate. It prevented any single facility from understanding the complete design, and it ensured that the loss of any one production node could not halt the program. It also served a counterintelligence function. Workers at the Fisher Body Division's Grand Blanc Arsenal in Michigan, one of the program's central manufacturing sites, were told they were producing an upgraded Sherman variant. The cover was maintained throughout development. No worker on the floor understood what they were actually building. The weapon around which the entire vehicle was designed was the 90mm M3 gun. Its lineage came directly from the 90mm anti-aircraft cannon already in widespread American service, a weapon with a well-established performance record in both European and Pacific theaters. Adapted for tank installation, it fired a 24-pound armor-piercing round at a muzzle velocity exceeding 853 meters per second. The standard M82 APC round could penetrate 119 millimeters of rolled homogeneous armor at 500 yards, sufficient to defeat Tiger I frontal plate at the engagement distances most commonly encountered in European combat. The T-30 E16 HVAP round, incorporating a tungsten carbide penetrator core, raised that figure to 221 millimeters at the same distance. That number was enough to threaten even the King Tiger's frontal armor under the right conditions. The engineers did not stop at the gun. The Sherman had failed in multiple categories, and the replacement addressed each one systematically. The hull was redesigned with sloped armor using cast construction methods that distributed the kinetic energy of incoming rounds more effectively than the Sherman's flat welded plate. The turret was produced as a single large casting, a manufacturing achievement that required capabilities German industry had never developed for components of this size. German turrets were assembled from multiple welded sections, introducing potential weak points at every seam. The American casting produced a structurally continuous surface with no such vulnerabilities. The Ford GAF V8 engine delivered 500 horsepower and demonstrated a reliability record that stood in direct contrast to the Maybach HL 230 power plant used in both Tigers and Panthers, an engine that experienced chronic overheating and mechanical failure under extended operational stress. The transmission, which German technical officers examining a captured example would later describe as representing engineering sophistication they had not anticipated from American manufacturers, provided smooth operation across terrain conditions that tested German mechanical systems to their limits. Two features distinguished the Pershing from every German tank then in production. The gun stabilization system allowed accurate fire while the vehicle was in motion, a capability the Tiger I physically lacked, requiring its crew to halt before engaging. And the wet ammunition stowage system, which surrounded propellant charges with a liquid-filled jacket, dramatically reduced the risk of catastrophic internal fire. The Sherman had earned the nickname Ronson among Allied crews, a reference to the cigarette lighter brand and its reliable ignition. The Pershing was designed specifically so that name would never apply. The first 20 production models were completed in January 1945. They were wrapped in waterproof sheeting, assigned false cargo codes, and loaded onto ships at the Port of New York before dawn on January 15th, positioned in the holds behind rows of standard Shermans. The selected crews had trained in isolation at Fort Knox since November 1944. Under court-martial level secrecy agreements. They crossed the Atlantic in 11 days through submarine-patrolled waters and arrived at Antwerp on January 26, 1945. German intelligence recorded no unusual shipping activity. No alert was issued. No recognition briefing was prepared. The weapon that would shatter 3 years of armored confidence had entered the theater, and no one on the German side knew it existed. The Pershings that arrived at Antwerp on January 26, 1945, did not go immediately into combat. They were transported by special train to the 3rd Armored Division's maintenance area near Düren, Germany, where final mechanical checks were conducted and crews completed last preparations under close security. By late February, 4 tanks were assigned to active task forces, 1 per formation, distributed among standard Sherman companies to minimize visual signature. Their orders carried a specific operational constraint that reflected how carefully the Army guarded this secret. Engage only Tiger or Panther-class vehicles. Against standard German armor, maintain cover. The weapon existed. The enemy was not yet permitted to know it. February 26, 1945. The town of Elsdorf, Germany. A T-26 E-3 Pershing, carrying the informal crew name Fireball, moved with its task force through the fractured outskirts of the town. Somewhere in the rubble of a collapsed building on the approach route, a Tiger I crew had established a concealed firing position. They identified the approaching column and engaged at close range, selecting what appeared to be a standard target. The 88mm round struck the Pershing's gun mantlet directly. The penetration killed the gunner and loader. The tank was disabled and came to a halt. It was the first Pershing lost in combat. It would not be the last, but what happened in the following 48 hours carried its own significance. American maintenance crews from the 3rd Armored's forward repair elements recovered the vehicle, assessed the damage, and returned Fireball to operational condition within 2 days. German crews captured in the same sector during subsequent operations later noted under interrogation that American heavy tank repair capability exceeded anything their own field maintenance units could achieve. The loss of the vehicle had been real. The loss was also temporary. That distinction was not lost on the men who observed it. The engagements that followed in the same operational area began producing reports that German command channels struggled to process. Pershing crews, operating under standing orders that prioritized Tiger and Panther targets, reported successful engagements at distances and angles that Sherman crews had never attempted against comparable German armor. A Panther from Panzer Brigade 106, operating under the established doctrine of engaging American vehicles from standoff range where the Sherman's 75mm gun was ineffective, was struck and destroyed by a single round at approximately 1,800 meters. The Panther's 80mm frontal armor, sufficient protection against everything American armor had previously fielded, failed to stop the incoming round. The crew had no time to identify what had hit them. The intelligence requests that moved up through German command following these engagements returned empty. No file existed for the vehicle being described. The recognition charts issued to German tank crews contained no matching silhouette. Training manuals, revised as recently as late 1944, contained no tactical guidance for an American vehicle with a gun of this apparent caliber and effective range. The Panzer training infrastructure had no answer because it had received no warning. There was nothing to warn about because no one in the German intelligence system knew the Pershing existed. German tank crews, with no official designation available, began using their own terminology. The vehicle became known informally as the Langkanon Sherman, the long gun Sherman. The name was operationally revealing. By framing the new vehicle as a Sherman variant rather than a separate design class, German crews unconsciously applied anti-Sherman tactical doctrine to a weapon for which that doctrine was actively dangerous. Standard procedure called for engaging American armor from distances where the 75mm gun was ineffective, roughly beyond 800 meters. Against a Pershing, that same standoff distance placed German crews squarely within the 90mm M3 gun's lethal envelope, while providing no defensive advantage whatsoever. March 6, 1945, Cologne. The engagement that occurred in the Cathedral Square that afternoon would become the most thoroughly documented tank duel of the entire Western European campaign. U.S. Army Signal Corps cameraman Jim Bates was present with a motion picture camera. The footage he recorded survived the war intact, and the sequence of events it documents is precise and unambiguous. A Panther from Panzer Brigade 106, commanded by Feldwebel Wilhelm Bartelborth, held a firing position behind rubble cover on the western edge of the square. The crew had operational experience, established fields of fire, and partial hull concealment. At 15:20 hours, Bartleborth's crew identified movement along the approach street. A tank with an extended gun barrel, lower profile than a standard Sherman, moving at combat speed toward their position. Bartleborth ordered engagement. The range was approximately 300 meters. At that distance, a Panther's 75mm high-velocity gun was operating well within its effective parameters. The crew fired first. The round struck the approaching tank's frontal armor and deflected upward. The spark trail was visible on the film footage. The round had not penetrated. Staff Sergeant Robert Early, commanding the Pershing designated Eagle 7, had already acquired the Panther before Bartleborth's crew fired. His gunner, Corporal Clarence Smoyer, had centered the crosshairs on the Panther's turret face and was waiting for the firing command. Early gave it. The 90mm round crossed 300 meters and struck the Panther's turret. The armor that had defeated dozens of Sherman rounds across France and Belgium split under the impact. Ammunition inside the turret began cooking off within seconds. The tank burned where it stood. A second German armored vehicle moved to intervene from a position further along the square's edge. It did not complete the maneuver. Eagle 7's crew engaged and destroyed it before it could bring its gun to bear. The entire sequence lasted less than 5 minutes. The Pershing continued forward without stopping. For Oberkommando West, the engagement at Cologne Cathedral was no longer a matter of fragmentary field reports from confused crews. It was filmed evidence, and German command would obtain its own confirmation through survivor accounts within hours. The Americans had introduced a new class of tank into the European theater. They had done so without any detectable warning, and it had been operating in combat for 10 days before the most public engagement of its brief career had just been recorded on film in the shadow of one of Germany's most recognizable landmarks. The question German command now faced was not whether the reports were accurate. The question was what to do about a weapon they knew nothing about, in numbers they could not estimate, distributed through American formations in a pattern they could not map. There was no immediate answer. There would not be one before the war ended. The Pershing that burned a Panther at Cologne Cathedral Square on March 6, 1945, did not disappear after the engagement. It continued up the street. But the records it left behind, the film footage, the survivor accounts, the physical evidence of deflected German rounds and a destroyed Panther, traveled in the opposite direction, upward through German command channels with increasing urgency. Within 48 hours, Oberkommando West had issued formal directives to all armored units on the Western Front, demanding immediate field reports on any contact with unidentified American vehicles. The responses that returned described a weapon that senior German commanders found genuinely difficult to accept. The Abwehr, German military intelligence, had maintained operational networks across Western Europe throughout the war. Those networks had demonstrated real capability. The introduction of the M4A3 Sherman with its 76mm gun in mid-1944 had been identified and reported, with enough lead time for German crews to receive updated engagement guidance. The development of the M10 and M26 tank destroyers had been tracked with reasonable accuracy. The Pershing program produced nothing. No report, no warning, no updated recognition chart. When German armored units began encountering the vehicle in late February 1945, the intelligence files contained no entry for it whatsoever. The operational security surrounding the T-26 program had been deliberately constructed to prevent exactly this outcome. The manufacturing effort was fragmented across 22 states and more than 300 subcontractors. No single facility held enough information to reveal the complete design. Workers at Fisher Body's Grand Blanc Arsenal in Michigan, one of the program's central production sites, had been told throughout the entire development period that they were manufacturing an upgraded Sherman variant. That cover story was maintained without exception. When finished vehicles were shipped to Europe, they traveled under false cargo designations, loaded behind rows of standard tanks, with waterproof sheeting covering their profiles. The counterintelligence discipline applied to the program was, by the standards of any belligerent in the Second World War, exceptional. But the intelligence failure had a deeper structural cause than operational security alone. Captured Abwehr documents and post-war interrogations of German intelligence officers reveal a consistent analytical assumption that had shaped German assessments of American industrial capability throughout the war. The United States had made a strategic choice to prioritize quantity over quality as a permanent manufacturing doctrine. The evidence supporting this interpretation seemed solid. The Sherman was produced in numbers that exceeded Germany's entire tank output several times over. American logistics emphasized replacement volume. The pattern appeared stable and predictable. What German analysts failed to model was industrial flexibility, the capacity of American manufacturing infrastructure to pivot from mass production of one design to mass production of a fundamentally different and more complex design without losing overall output momentum. German tank production had no equivalent capability. The precision manufacturing requirements for Tiger and Panther components, combined with chronic raw material shortages and a production system that had never been fully reorganized for wartime industrial scale, meant that German factories could produce one type of tank at a given rate or struggle to introduce a new design, but could not do both simultaneously. American factories, operating on different organizational principles with greater material access and purpose-built wartime infrastructure, could. German intelligence had never adequately accounted for this difference. When German technical officers gained access to a knocked-out Pershing in early March 1945, the inspection reports they compiled documented the gap between their assumptions and the physical evidence in front of them. The cast turret, produced as a single continuous piece, required manufacturing capabilities Germany had never developed for armor components of that size. German turret construction relied on welded multi-section assembly, introducing structural seams that a single casting eliminated entirely. The report noted this without qualification. The capability required to produce this component had not been assessed as existing in American industry. The Ford GAF V8 engine drew specific attention. At 500 horsepower, it matched the output of the Maybach HL230 used in Tigers and Panthers, but did so with a reliability record the Maybach had never approached. The HL230 was a capable engine operating consistently beyond its designed tolerances, prone to overheating under sustained combat loads, and requiring maintenance intervals that complicated operational planning. The American engine ran. German technical officers noted this with the precision of men who understood exactly what it meant for sustained armored operations. The gun stabilization system produced the most operationally significant finding. German engineers confirmed that the Pershing could achieve accurate fire against stationary targets while the vehicle itself was moving, a capability the Tiger I physically lacked, requiring a full halt before the gunner could engage with any expectation of accuracy. In a fluid engagement where time to first accurate shot determined survival, this difference was not marginal. The power traverse rotated the turret 360 degrees in 15 seconds. The wet ammunition stowage, surrounding propellant charges with liquid-filled jackets to prevent catastrophic internal fire, was noted as a standard feature, not an experimental addition. Each technical finding deepened the intelligence failure it documented. Germany had not simply missed a development program. It had fundamentally misread the industrial and engineering culture capable of producing such a program. By mid-March 1945, approximately 20 Pershings were operational in the European theater, with additional vehicles arriving on each successive supply convoy. German command had no reliable count of how many existed, no recognition protocol for identifying them at combat range, and no tactical doctrine for engaging them effectively. The directives from Oberkommando West demanded information that the intelligence apparatus could not provide. The gap between what was needed and what was available would not close before the war ended. German intelligence had failed to detect the Pershing. German technical officers had examined it and found engineering they had not anticipated. But neither of those failures, operational nor analytical, produced the most consequential damage of the Pershing's brief combat career. That damage was psychological. It moved not through command channels or technical reports, but through the informal networks of a fighting force. Conversations between crews, rumors passed at fuel points, accounts shared between veterans who trusted each other's judgment. By late March 1945, what those networks were transmitting had begun to alter the behavior of entire armored formations. The pattern was visible first in the maintenance records. German armored units operating on the Western Front in late March and early April 1945 showed a marked increase in vehicles declared non-operational for mechanical reasons. Recovery teams dispatched to retrieve these tanks filed reports that told a different story. They found vehicles with thrown tracks, a repair requiring several hours of labor but no specialized equipment. Tanks with empty fuel tanks positioned within range of available supply points. Vehicles with loose track pins, minor transmission faults, small arms damage to external fittings. These were the kinds of mechanical problems that experienced crews in the same units had routinely corrected under fire in France and Belgium 6 months earlier. They were now sufficient justification for abandonment. The change in behavior was not random. It was concentrated in sectors where Pershing contact reports had circulated, and it correlated directly with the timing of those reports reaching individual units. American after-action reports from the same period document a new operational pattern on the German side: disengagement at first contact, withdrawal from defensive positions that should have been held for days, and a notable reduction in the German tendency to counterattack American armored advances that had characterized defensive operations through the winter of 1944 to 1945. The material situation had not changed significantly in the weeks following Cologne. What had changed was the calculation German crews were making about what they were likely to face. The core of that calculation was identification uncertainty. A Pershing and a Sherman, observed at ranges beyond 400 meters in the smoke and reduced visibility of urban or forested combat, were not easily distinguished. The hull profile was lower on the Pershing, the gun barrel measurably longer. But these differences required time and clear sight lines to confirm. In combat, neither condition was reliably available. German crews approaching an American armored position could not know whether they were engaging Shermans, vehicles their guns could handle with confidence, or Pershings, which had demonstrated the ability to defeat their armor at ranges they had previously considered safe. That uncertainty, sustained across every engagement, degraded the offensive confidence that German armored tactics required to function. American prisoner interrogation reports from this period document the psychological mechanics of this process with unusual clarity. The accounts compiled by 3rd Armored Division G2 intelligence officers describe veteran crews, men with confirmed kills in multiple theaters, with years of frontline experience, articulating not tactical frustration, but something more fundamental. They described the removal of a certainty they had operated under since 1942. For 3 years, regardless of numerical disadvantage, regardless of retreat, regardless of casualties, German tank crews had maintained a specific professional confidence. Their machines were technically superior to anything the Allies could field. That confidence had functioned as an operational resource, sustaining combat effectiveness through conditions that would otherwise have broken unit cohesion entirely. One interrogation report, compiled in April 1945 from the testimony of a King Tiger crew captured near Paderborn, is particularly precise. The crew's commander, a Feldwebel with documented kills on both the eastern and western fronts, had not encountered a Pershing directly. He had read the intelligence reports from Cologne and subsequent engagements. His response was to issue standing orders to his crew to avoid engagement with American armor unless contact was unavoidable. When asked by the interrogating officer to explain this decision, his answer was categorical. He no longer knew what he was fighting. That statement, from a veteran King Tiger commander whose vehicle carried 150 millimeters of frontal armor and an 88 millimeter gun capable of defeating any Allied tank then known to exist, represents the precise moment at which psychological collapse and tactical paralysis became the same thing. The Waffen-SS armored formations, which had been selected throughout the war on the basis of ideological reliability as much as military competence, experienced this collapse in a specific form. National Socialist doctrine had framed German military technology as a direct expression of cultural and racial superiority. The Tiger had been publicly positioned not merely as an effective weapon, but as physical proof of German engineering genius. The Pershing's existence challenged that framework at its foundation, and unlike a tactical defeat, which could be attributed to circumstances, numbers, or terrain, it offered no available rationalization. American factory workers in Michigan and Ohio had built a tank that could kill Tigers. The ideological system had no category for that outcome. By April 1945, the effects had become measurable at the formation level. U.S. Army intelligence reported a pattern that had no precedent in the Western European campaign. German tank crew prisoners were reaching collection points ahead of infantry units from the same formations. Throughout the war, the established pattern had been the reverse. Tank crews fought to the last, while infantry units surrendered first. The reversal was not explained by combat losses or encirclement. It was explained by decision. Crews that still had operational vehicles were choosing surrender over engagement with an enemy whose capabilities they could no longer predict. 20 Pershings were in active combat across the entire Western Front. The German armored force, which had held lines against overwhelming numerical odds for 3 years on the strength of technological confidence, was adjusting its behavior across every sector in response to those 20 tanks. The weapon that had produced this outcome had been in the theater for less than 6 weeks. Germany surrendered on May 8, 1945. The war in Europe was over. The accounting that followed, of men, machines, territory, and decisions, would occupy historians for decades. Within that accounting, the M26 Pershing occupies a position that the raw numbers alone cannot adequately explain. By the date of surrender, 310 Pershings had reached the European theater. Of those, approximately 20 had seen actual combat. The statistical record of what those 20 tanks achieved in direct engagement is too limited to support meaningful kill ratio analysis. Military historians have noted this consistently, and the point is valid. But the numbers that matter most in the Pershing story are not the ones recorded in tank versus tank engagement logs. The production comparison is where the industrial reality of the war becomes fully visible. Germany produced 1,347 Tiger I tanks across the entire war. From the first deliveries in mid-1942 through the final production runs of early 1945. King Tiger production reached 492 vehicles total. These figures represent the maximum sustainable output of German heavy armor manufacturing under full wartime mobilization, drawing on the precision engineering traditions of firms like Henschel, MAN, and Krupp, consuming raw materials that Germany was sourcing at increasing difficulty and cost as the war progressed. Each Tiger required weeks of specialized machining. Each King Tiger demanded even more. The production infrastructure was optimized for quality and could not be significantly accelerated without compromising the characteristics that made the vehicles effective. American factories, which began serious M26 production only in late 1944, had produced 2,212 Pershing tanks by October 1945, 5 months after the European war ended and while Pacific operations were still ongoing. Fisher Body's Grand Blanc arsenal in Michigan alone accounted for 1,739 of those vehicles. The Detroit Tank Arsenal, operated by Chrysler, contributed 473 more. The assembly lines, once retooled from Sherman production, could complete a Pershing in hours. The organizational infrastructure that made this possible, the network of suppliers, the purpose-built factory floors, the trained workforce, had been constructed and refined over 3 years of wartime production, and represented an industrial capability Germany never possessed at any point in the conflict. The post-war technical assessment of the Pershing, conducted by American and British armor analysts with access to captured German vehicles for direct comparison, produced conclusions that were more measured than the psychological response the tank had generated in combat. German engineers examining captured Pershings had identified genuine strengths: the single-piece cast turret, the stabilized gun system, the reliable engine, the wet ammunition stowage. They had also identified real weaknesses. The transmission proved mechanically unreliable under extended operational stress, contributing to breakdowns that complicated unit readiness in ways that German transmission systems, for all their other faults, did not replicate in the same pattern. The 90mm gun's rate of fire was slower than the German 88mm. The armor, though well-angled, was thinner than King Tiger plate in absolute terms. The consensus conclusion reached by post-war analysts was that the M26 Pershing was, measured objectively against German armor, roughly equivalent to the Panther, superior in gun stabilization, crew ergonomics, and engine reliability, inferior in armor thickness and rate of fire, broadly comparable in firepower and mobility. It was not the overwhelming technical achievement that German crews had imagined after the Cologne engagement. The psychological impact the weapon generated had exceeded its material capabilities by a significant margin. That discrepancy is itself one of the most instructive observations the Pershing's history offers. The myth of a weapon can operate as powerfully as the weapon itself, provided the conditions for belief are correctly established. The lesson that German military planners drew from the Pershing experience, formalized in post-war Bundeswehr doctrine, was not primarily about tank design parameters. It was about industrial capacity as a strategic variable that cannot be neutralized by engineering excellence alone. The German military had entered the Second World War operating under a strategic assumption that precision engineering and tactical superiority could compensate for disadvantages in raw material access and production volume. That assumption had shown stress fractures throughout the war. The Pershing made its failure explicit. American industry had produced a heavy tank that matched German quality while maintaining production rates Germany could never approach, and had done so without the German intelligence apparatus detecting the program until the vehicles were already in combat. German tank veterans who survived the war and returned to civilian life carried this experience into their post-war accounts with consistency. Their memoirs and recorded testimonies do not describe the Pershing as the weapon that defeated them in the field. The sample of actual combat engagements was too small for that framing to be accurate. They describe it instead as the weapon that removed the last available reason to believe that continued resistance could produce a different outcome. Men who had maintained combat effectiveness through years of numerical disadvantage, territorial retreat, and catastrophic casualties had done so by holding to one certainty: German tanks were better. When that certainty was removed, not by battlefield defeat, but by documented evidence that American engineering had produced a comparable weapon, the psychological foundation of their continued resistance was gone. At Fort Knox, a Pershing and a captured King Tiger stand in the same display hall. The technical placard between them notes their rough equivalence in performance terms. It is an accurate summary of what post-war analysis concluded. It does not record what a German crew experienced in the spring of 1945 when the long barrel of an M26 appeared through the dust of a ruined German street at a range their doctrine told them was safe, and their round deflected off its frontal plate. That moment is not a specification. It is not captured in production statistics or armor thickness tables. It is the point at which 3 years of professional certainty met a single piece of contrary evidence, and the certainty did not survive the encounter. In the final accounting of what the M26 Pershing contributed to the end of the war in Europe, that moment, repeated across 20 tanks, across 8 weeks, across an entire armored force, is the number that matters most. That is the story of the M26 Pershing, a weapon that changed the course of armored warfare not through the scale of its combat record, but through what its existence proved. 20 tanks, 8 weeks, and the end of a certainty that had sustained an army for 3 years. If you found this history valuable, subscribe to the channel. It is the most direct way to support this work and ensure more stories like this one reach you. Thank you for watching, and we will see you in the next video.